Good afternoon, everyone. Welcome to our event today. We are extremely glad to have all of you gathered in this extraordinary faculty development program organized by Entrepreneurship Development Cell and Institute Innovation Cell. I am Grindelia Chakraborty, a final year student of BBA in Bengal College of Engineering and Technology, and your host for today. It's an honor, graced by the presence of such an esteemed faculty members and guests gathered here. Before starting the session, I would like to extend a warm welcome on behalf of our college to all of you. Now, it's my pleasure to introduce our session chair, Mr. Shiv Prasad sir. We are honored to have him here to guide us through today's discussions. Moving to the session, the today's topic is research design and writing with multi-criteria based soft computing models. I am delighted to introduce our speaker, Dr. Sanjeev Biswas sir. He presently teaches at MIT University, Kolkata in area of decision sciences and operations management. He did his PhD under the guidance of Professor Gautam Bandyopadhyay in management studies from NIT Durgapur. He has 2 decades of experience working in industry and academics. He has been a visiting faculty and external examiner for MBA dissertation projects and Viva Voce for Indian Institute of Foreign Trades, Kolkata for the last 4 years. He has published more than 100 papers, including papers in Scopus, index journals, and proceedings such as Information Science, Annals of Operations Research, FUSME, DMAME, and others. He is a regular viewer and editorial board member of 20 plus SCI index journals, including Applied Soft Computing, Technology Forecasting and Social Change, Computers and Industrial Engineering, Expert Systems with Applications, OpSearch, Reports in Mechanical Engineering, and many others. He is among the 2% researchers in the world 2024 in Standard University and received several Best Paper awards in national and international conferences. He holds 3 patents to his credit. He has delivered several invited talks as a research person, trainer, and expert. His research interests including supply chain management, MCDM, soft computing, technology management, and sustainability. Please join me in welcoming Dr. Sanjeev Biswas sir as he shares his expertise on this topic. Over to you, sir.
So I guess I can start now. First of all, thank you very much for your kind introduction. Indeed, it's a pleasure to see that students are taking the front initiatives to introduce or hosting these sessions. And I am very pleased to have such kind of experience here. I must be grateful to the organizers for inviting me, particularly my good friend, Dr. Shantanu Modak, who called me out for delivering a lecture. I'm so sorry that I could not join on time because of some academic assignments. But nevertheless, I would not take much of time for introduction and something like that. So let me straight away go to my presentation. So, Green, can you just confirm me whether you see this screen or not?
Yes, sir.
And if I make it enlarged version, can you see this?
Yes, sir.
Just you check that can you see the change in the slide?
So can you please repeat?
Change in the slide is
Yes,
slides are
yes,
changing?
yes, sir.
Yes,
It will change.
perfect. So, all right. So let me start with my topic, research design and writing with multi-criteria based soft computing models. To begin the discussions, first of all, I must confess that research is an ongoing journey. And every year, every time, every day, we researchers work passionately to achieve something new. And we would like to contribute for the cause of society and academic fraternity. So research is an ongoing journey. It happens, it goes on day by day. So this is something we do every day. So with this little bit of experience, I have set this topic: research design and writing with multi-criteria modeling. So my agenda would be, first of all, I would give a conceptual foundation of multi-criteria modeling, then little bit about soft computing. Then, since the topic has one part called research paper design and writing, so I would show uh, two papers where soft computing based MCDM models are applied. And there I would explain that the step by step approach that one should follow to design and write a research paper. And end of the sessions, I would touch base on certain aspects of research paper writing, some general remarks. To start the decision, first thing is that multi-criteria decision making, the first part is decision making. So what is decision making? Decision making means I have to select a favorable alternative or best possible choice while satisfying the underlying conditions. For example, a teenage girl who knows four boys whom she likes and has to decide any one of them with whom she wants to marry. But this is simply like that. Four available choices are there. She has to select any one choice. Now, how does she select one particular boy? Now, apparently, if there is one considerations that the boy which has a good character, that person with whom I would marry, then it's a scoring method. It may be salary, it may be the culture, it may be the qualification. But if I select any one aspect and I want to select a best possible alternative, then it is simply a scoring methods. But if the problem becomes such that all of the criteria or attribute has to be considered, but before selecting the best possible choice, then the problem becomes very much critical. I'll take another example. Let's say this part is very important to understand the MCDM problem. Let's say I want to select a smartphone. So if I want to select a smartphone, one of the possible consideration is battery. So we all want that the smartphone should have a long battery life. Now, if the battery life is the only consideration, then though the phone which has a higher battery life, like in form of mAh, then I select that particular phone. But if I go for cost is another aspect, and at the same time, camera quality is another aspect. So then if I consider these three criteria, it might be perfectly possible that a particular option has a good battery life, but the cost is high. It might be possible that the cost is low, but the camera quality is very pathetic. So it means these criteria or attributes which are involved in the decision making, they are often in conflicting to each other. And when a decision maker wants to select a particular option, then he or she has to satisfy the effect of all these things. In other words, it is called trade-off. So trading off the effect of the criteria to select the best possible choice is called multi-criteria decision making. So multi-criteria decision making is a problem where I have multiple objectives, multiple criteria based on multiple criteria. For example, the previous example, I have long battery life, good camera quality, but at lesser cost. So multiple objectives reflecting the multiple criteria is there. The criteria set is conflicting to each other, and I have finite number of alternatives. So I want to select the best possible course of action or alternative. That is problem of MCDM. Now, MCDM problem is of two categories. The first one is the MADM, that is multi-attribute decision making, and the second one is MODM, multi-objective decision making. Now, I'll just explain the problem a bit. Suppose you have finite number of alternatives called A1, A2, A3, A4, A5. So let's say you have finite five number of alternatives. So you want to buy one smartphone and you have five choices. Now, as I mentioned, there may be several criteria, C1, C2, C3, let's say four criteria is there. So this is called my battery, this is my camera, this is my what do I say? This is my camera quality. This is my weight. This is my weight, and I can say this is my sound, and this is my price. So you understand that I want more battery life, good camera quality, better sound, but at a lesser price. So that means each of the alternative has a value here. For example, A1 may be having some value for battery life, for camera quality, for sound, and for price. Similarly, A2 is also having same values. So this particular matrix is called decision matrix. So I form a decision matrix where I have finite number of criteria influencing finite number of alternatives with an objective to select the best possible choice. Now, if this is the case, then in this case, my objective is to select any one of the alternative while satisfying the requirement of this criteria. So this is a problem of MODM. Now, what is MODM? MADM? Now, what is MODM? Suppose I don't have any choices. I don't have any possible alternatives. Now I want to select or I want to find out a suitable option while satisfying all these criteria. For example, I know I have C1, C2, C3, C4. So say for example, I want to have a mobile phone which is having 6,000 mAh battery, which is having, let's say, 250 or let's say, what can I say, a megapixel camera. That means 64, 128 megapixel camera. I can have a good quality sound, quality voice, SNR ratio, sound signal to noise ratio less than zero point 0.1, and I want it as a price of 5K. Suppose I set this condition. C1 value is 6,000, C2 value is 128, the camera sound quality, camera signal to noise ratio is less than zero point 0.1, and price at 5K. But I don't have any choices. I don't have any alternatives. I only have the conditions. Now, with respect to this condition, if I design a particular alternative or if I design a choice, then it is a problem of MODM. So in case of MADM, these are called criteria, and I have alternatives I have to select. And in case of MODM, these are called objectives. So I have to optimize multiple objective to make a decision. So that is the difference between MADM and MODM. It is better illustrated with this picture. So you have speed and space, do two aspects. So if we want speed, increase the speed, then I could have the possible choice is Ferrari. I should have the Ferrari car to increase the speed, highest speed in the field. Now, if my consideration is space, then I go for bus, Volvo bus. But if I want to satisfy speed and space both, then I should have selected the middle one, Mercedes car. That means multi-objective optimization is basically satisfying the conditions under constraint. We come up with a great design. In this particular talk, I would focus on MADM. As I said, this part is already covered. Now, if you look at the several techniques of MADM, you will see that enormous number of techniques are there. In case of MADM problem, there are two aspects. So I have a decision matrix like this, A1, A2, A3, AN, AM, and with a finite number of criteria, C1, C2, C3, CN. So this is my decision matrix. So in case of any MADM problem, there are two aspects. One is the criteria weight. That means I have set the criteria, but I may not have equal priority for all the criteria. So all criteria may be, just a minute, the criteria set may be of different priority. So that I decide through criteria weight, and then I need to select any possible alternatives. So I need to rank them. So these two are the steps of any MADM problem. Now, if you look at the criteria weight, there are many methods available. Now, this decision matrix can be formed by two types of information. One is called objective information, and one is called subjective information. The two type of information is there to form this decision matrix. One is the objective information, and second one is the subjective information. What is objective information? Objective informations are those which are quantified data available, published. So that is called objective information. For example, smartphone example, every information, if I collect the specifications, the battery life, camera quality, weight, price, these are all objective data, numeric data. This is all quantified data. Now, suppose I ask a number of users that what is your experience, and based on your experience, you select any particular alternative. Then they opine, or they give their opinion that I like the aesthetics very much, but I don't like the functioning of this phone. I do not enjoy this phone. I do not like this brand, so I may not like, I strongly like, strongly dislike, or may not, maybe like, maybe dislike. So that means when there are subjective rating or ranking is there for each alternative respect to the each criterion, then it is a subjective opinion based decision matrix. So decision matrix can be of two categories. One is the objective information based, one is the subjective information based. But based on that, the criteria weight, there are several methods available. In fact, the domain of MCDM is just like a ocean where several information, several uh, methods are available. So, like the methods like popular methods like AHP, analytical hierarchy process, DMATL, critique, all these methods differ in the aspects like what is the construction of the decision matrix, what type of normalization is used at all, how do I calculate the appraisal scores. So that are the few features that segregate different methods. If you talk about the ranking, there are many methods like the good old Topsys methods, Electre, Vicar. These are all quite early days methods. Coming to the recent kind of thing, that is Cocoso, Marcus, then SRP. There are many such methods available. Now we come to soft computing. So what is soft computing? Soft computing is a kind of field which deals with impreciseness. It deals with natural selection, it means that where we need to go for approximation. In fact, uh, in real life world, information, there are a lot of situations where you face the uncertainty because of imprecise information. So to tackle those impreciseness, Professor Jade coined this term soft computing in 1992. What are the things included in the soft computing domain? It's a vast field. It encompasses fuzzy logic, genetic algorithms, machine learning, artificial neural net, expert system. There are so many domains under the umbrella of soft computing. In this particular talk, I focus on this aspect, fuzzy logic. So if you look at this fuzzy logic family, there are a lot of developments have taken place, starting from the age-old concept of fuzzy 1965, proposed by renowned scientist Dr. Professor Lofty Jade. Afterwards, there are many extensions, expansions took place in the domain of fuzzy sets. Okay, all right. So to start with the concept of fuzzy sets, let me explain with a small example, very primitive example, I can say. Let's say this is my choice basket. This is my choice basket. So I want to select some element for this basket out of the available choice. Let's say I set a basis that 80% and above marks holder are entitled to be included in the choice basket. So I have many students there. They all have got their, let's say, class 12 marks, and I want to admit them in my course, BBA or bachelor's level. So I set a condition that whosoever else has got 80% and above, they are shortlisted. After that, PI will take place, personal interview will be conducted, and those would be selected, they would be offered admission letter for the course. Now, if I say that basis is 80% and above, anyone which is having 80 and above can enter, rest is not eligible to enter here. So my decision basis is pretty simple. 80%, if it is 80%, come in. If you don't have 80%, below 80%, get out. So that is my simple. So this type of formation of crisp basket or set is called crisp set. And now, if I set the basis from here 80%, if I set only the good academic, if I set the good academic background students can enter, good academic background students can enter. Next, as per our, we all know, as per our UGC guideline, it is said 55% and above marks are considered as academically good candidates. Now, in that case, who will be the persons that would, those will be eligible? Because anyone who has got 56, as per UGC definitions, good academic background, anyone which has 95%, that is also good academic background. So this means this term good becomes, what do I say, vague. And here comes the importance of fuzzy. So I would allow 55% and above students, but if a students come with 55%, that would be the least chance of membership. And the student which comes with 99% above, that would be having the best chance of enter. That means, in other words, I define a membership degree called mu. So that means 99% and above, 90% and above, they have the good membership value. The person who has got 100%, for his or for him, the membership value is 1. And the person who has got 54.9%, even not 55%, the membership value is 0. So I have many elements and I define a membership function called mux. And mux equals to 1. When mux equals to 1, it is almost certain. It is certain. When mux equals to 0, it is discarded. And when mux is in between 0 to 1, that is relatively relative member, or is a varying degree of membership. That is the funda of fuzzy set, which we call type 1 fuzzy set. Now, come, this model has worked a lot been by many researchers. Now, Atomosov in 1986, they have proposed a very interesting domain called intuitionistic fuzzy sets. What it says membership, variable degree of membership is all right, but it might be perfectly possible that I assign a membership value to someone, but that does not mean I dislike that. I may dislike the element also. So that means each element has a membership degree as well as has a non-membership degree. And here comes the introduction of VX, that is degree of non-membership. So Atanasov proposed intuitionistic fuzzy sets with a condition that mu x plus Vx is less than equals to 1. That condition is a less greater than equals to 0 and less than equals to 1. Now, in many cases, it is possible that mu x plus Vx is inequality doesn't hold good. For example, if I set 0.8 is the 80% chance of the membership, but at the same time, there is 60% chance of the non-membership also. So in that case, this inequality doesn't hold good. Then people go get into the domain of, in the series, the domain of Pythagorean fuzzy sets proposed by Eager. That says mu square plus b square less than equals to 1. So if I square it, 0.64, 0.36, it is 1. So that means this inequality holds. But in some cases, still pending, where mu 8 and zero point 0.7 may be there. In that case, it doesn't hold good. So people go for a generalized version, which is called Q-rang orthopair fuzzy, that is mu to the power q plus b to the power q should be less than equals to 1. So I set the value of q so that I have enough flexibility. And this picture fuzzy and nucleosoid fuzzy sets, they have another nucleosoid fuzzy sets, another membership function apart from mu. That function is called degree of hesitancy, mu. So it is basically mu plus nu plus v less than equals to 1. And this picture fuzzy set has another membership functions, that is mu plus nu plus v plus something which is called degree of refusal, and that is less than equals to 1. So this is in short some of the uh, fuzzy families. So problem solving steps are there: wait, find out, ranking, and once you get the ranking, you need to check the sensitivity of the analysis. So with this, I move to uh, the problem. I move to another area, that is the problem proper case study, because I now move to the second part of my presentation, that is how to write or how to develop a problem with soft computing based MCDM model. So let's start with this problem. This is a very recent type of problem. It talks about this particular problem is talking about blockchain technology selection in the logistic industry. Now, with a novel MCDM pair of Pharmatin. So here I use we use that fuzzy called Pharmatin fuzzy set. For the recapitulation of or for the continuation, for classical fuzzy set, we have only one membership function, that is degree of membership, for positive membership, that is mu, and that value can lies between 0 to 1. So in case of IFS, the membership function is two membership function is there. There is mu and v, and that is less than equals to 1. In case of Pythagorean fuzzy set, the values are two membership function, but that is hold mu square plus v square plus less than equals to 1. In case of Fermatin fuzzy sets, the condition is mu to the power q plus v to the power q less than equals to 1. So the continuation has taken place because of giving flexibility to the decision maker so that they can select the values of mu and v as per their choice. So they select the values so that this inequality holds good. In case of Qram, it is mu to the power q plus v to the power q less than equals to 1. We call it as a Qram orthopair fuzzy set. And there is a recent addition, PQ Quasirang orthopair fuzzy set, where we have mu to the power p plus v to the power q less than equals to 1. So there are this fuzzy sets, intuitionistic fuzzy set family has been extended over the years like this. So in this particular case, we have Fermatin fuzzy sets used. And this is obviously you understand this is a subjective expert opinion based study. So for aggregation purpose, we use Dombey aggregation. Now moving forward, the first part of so for the research problem is the abstract. The first part of the research problem is the abstract. Now, in case of abstract for MCDM based model or in general, any MCDM based model or in general, the three lines, first 2 or 3 lines, you state the background of the problem. That means, suppose a reader who doesn't know what is called fuzzy, who doesn't know what is called logistics, who doesn't know what is called blockchain, who doesn't know your area of work, and the title, by always title doesn't speak everything. So if he or she doesn't know your work, and she has to read your work, so to develop the interest, the first few lines you talk about this, what is the problem area, that is the background of the problem. So this particular thing is described 2 3 lines, sometimes it goes to 4 5 lines also, so depending upon the problems itself. Next, you just try to write straight away what is the problem. That means, what is your objective, what is your objective. Then first is the background to sensitize, then you go to the objective, what, why. Then you go to the approach, how you go for this uh, research, that what is how you design these things. And then indication of result, that what you have found. Then why people should read your work, that is originality or value. So this part has to be written there. So this is the in general, not only for my MCDM based method, but also for any kind of method. This is the way that the abstract is crafted. Next, I go to this introduction part. I will touch base on these things later on. This particular problem is actually dealing with kind of challenges that any logistic service provider encounters when the service provider actually wants to implement blockchain technology. And this abstract section, we have highlighted all this part. What is blockchain? Why is it important? How is it revolutionizing the uh, logistics industry? What kind of challenges are there? Advantages are there? This is the background of the problem, sensitizing. That why have we taken this problem? Now we slowly get into the motivation of the study. We slowly get into the motivation of the study. So we make the motivations, that what are the things have been done, what are the things have not been done, and what sensitized us or ignited us to undertake this research. Then we revisit the past, that is the literature review. So we have revisited the past, and then gradually, this is the interesting section, we have to set the preliminaries of Fermatin fuzzy sets. As I mentioned, the conceptual definition is mu to the power Fermatin fuzzy set is one, which holds the inequality membership function to the power q plus non-membership function to the power q should be less than 1, 0 less than equals to 1. So I hold this relationship, and we move forward. Now, one may ask a particular question, that since we have another option called mu to the power q, mu to the power q, this part, this is a q-rank orthopair fuzzy set. This is a q-rank orthopair fuzzy set. So this fuzzy set is available. If we put q equals to 1, it becomes IFS. If we put q equals to 2, it becomes Pythagorean fuzzy sets. If we put q equals to 3, it becomes Fermatin fuzzy set. So Q-rank orthopair fuzzy set is a generalized version. And why people should then, if Q-rank orthopair fuzzy set is available, why one should use Fermatin fuzzy set? Now I'll tell you why it is important and essential to use Fermatin fuzzy sets. It's because the fact that conceptualization and visualization of Q-rank orthopair fuzzy set is a bit complex thing than Fermatin fuzzy sets. Because we all know that this Pythagorean fuzzy set is basically drawn on a plane. These two axes are there. In case of Fermatin fuzzy sets, we have 3 axes. And at max, 3 axes can be easily visualized, but Q-rank is a Q-axis form, so that is sometimes difficult to visualize. So Fermatin fuzzy sets has its own benefits. So this is the flowchart that for it is good to have a flowchart in any research paper writing, including the MCDM problem, so that one can understand what are the steps and how it is followed. For example, here the Fermatin fuzzy sets things are mentioned. Then testing is mentioned. How did we arrive at the criteria? That is also mentioned. Fermatin fuzzy set, Pythagorean fuzzy sets. This diagram explains the thing. This is your IFS, mu plus b less than equals to 1. This is your Pythagorean fuzzy sets, mu plus b square, v square plus v square less than equals to 1. And this is your Fermatin fuzzy sets. Now, these are some of the properties of Fermatin fuzzy sets and all. Some properties are there. This important is that the score function, how do you find out the score? The score function is found by deducting this what amount of excess of membership function over the non-membership one. This is a classical way of defining the score value. Gradually, there are many such ways of defining the score value. Latest one is this. Now, these are the some of the aggregation operator. We define some of the aggregation operator. What is the aggregation operator? Because aggregation operator says that suppose there are multiple fuzzy numbers that each of the experts opine, so that is a fuzzy number, Fermatin fuzzy number. Now, if we have to arrive at a conclusive rating, then we have to aggregate that. The simplest one is Fermatin fuzzy weighted aggregation. I hope I should make it more bigger. So Fermatin fuzzy weighted aggregations is this is sum of weight of the decision maker multiplied by the rating mu, sum of the weight of the decision maker multiplied by the non-membership. So in this way we can delay. But in our paper we use the Dombey aggregation because this is a very straightforward aggregation and we don't have any flexibility to check the sensitivity. So Dombey norms and co-norms provide you a simple yet powerful measures with the availability of a parameter called beta. By varying the value of beta, I can what do I say? I can assign the different priority to the membership and non-membership function, and I can reach to a definition. So this is done, and in this particular case, we used a method called Foucault method. Now, this requires a bit explanation. Now, suppose I have two choices, two criteria, that is C1 and C2. Now, let's say these two criteria, let's say this rating, that means C1 is rated 5 by the experts and C2 is rated 4 by the experts. So if I compare this, then how much C1 is greater than C2? That is 5 by 4 that I get equals to 1.25, 1.25 times. So that means C1 is more than 1.25 times important than C2. Now, if this happens, then if I find out the weight of C1, that is W1, and the weight of C2, that is W2, and if I divide that, then it should give me the same thing. If C1 is 1.5 times important than C2, then weight of C1 ideally should be 1.25 times of C2. But in reality, always this doesn't happen. So this comparative priority C1 by C2, C1 2, this always doesn't happen. Sometimes it happens, the calculated weight, if that is not happen, that means if W1 by W2 minus the comparative priority of 1, 2 is equals to 0, that means I am fully consistent. So this is called full consistent, fully consistent, full consistency. That means if C1 is 1.5 times 25 times important than C2, then weight of C1 is also 1.525 times more than C2. So the values must be equals to 0. But in reality, it doesn't happen. So there is a defined difference called psi. So that psi is called deviation from full consistency, or which is called DFC. So Foucault method works on this phenomena. So for each pair of criteria that compares each pair of criteria, C1, C2, C2, C3, C1, C3. So it compares a global comparison and it tries to find out whether this inequality holds. Now, in mathematics, there is another important thing. If W1 by W2 equals to psi 1 by 2, then W2 by W3, W2 by W3 is psi 2, 3, then W1 by W2, the W3 should be equals to W1 by W2 into W2 by W3. So that means this is what known as in mathematics called transitivity property. Transitivity property. So FUCOM also works on transitivity property. So it checks two conditions, whether this part is all right. So ideally, this is not happen. So in realistic case, ideally should be there, but in realistic case, it doesn't happen. So in realistic case, this absolute value is less than equals to the parameter called psi. And it also checks if that holds good, that means W1 by W3, that is equals to psi 1 2 into multiplied by psi 2 3, that should be also less than equals to psi. So that means this. So Foucault works with this principle and it forms an inequality equation like this. As I said, this is the property phi. That means is a comparative priority of nth criterion with respect to n plus 1th criterion. And I form the equations like this. This must be less than equals to a very small number called psi and chi, and this is what comes from transitivity property. This has to be less than equals to chi, and weight must be equals to 1. So Foucault works with this principle. The principles are mentioned here. Next, so I said the two aspects are there. One is the determination of criteria weight. Second is the ranking. So ranking, there are n number of methods. This method MICA, this works on certain. So as I said, this is a decision matrix. Is C1, C2, C3, Cn, and A1, A2, A3, Am. So M cross N decision matrix. This is the M cross N decision matrix is there. So I form this decision matrix, and then first stage is if this method works with, it sets the priority of any alternative. So had it been a case that I give equal distant priority, then it should have been equal. That means if all alternatives for a particular criterion given equal importance, then the priority value should be equals to 1. Now, this is in this way, we form the theoretical rating matrix. So theoretically, all alternatives should be given same importance, same priority, and we have the weight calculated. So weighted priority is same. Now, in reality, it doesn't happen because priority values changes. To find out that, first we go for normalization. Now, why normalization is important in a MCDM based problem? You know that I have these alternatives in place and I have this criteria in place. That now these all criteria are heterogeneous in the sense that they have different range of values, they have different unit of measurement, they have different way of definitions. So when I use all the effect of this criteria to compare the available choices, I need to nullify all those difference in ranges, scales, values, unit of measurement. So I want to fix a common platform so that I can compare these alternatives. So for that, go for normalization. There are many methods available for normalizations. In this particular case, we use a kind of normalization which is called linear max-min normalization, where I use this xj plus is the max value, this is the mean value. So in case of beneficial criteria, that means for whom I want higher value, in that case, it should be uh, away from the minimum value as much as possible throughout the range. Now, in case of this criteria called non-beneficial criteria, it means I want something called, I want that the value should be lower possible. So in that case, it might be away from the positive value. That means if a criteria, there are two set of criteria. There's a mean and this is a max. Now, if that is a beneficial criteria, I always want a higher value. So the value should be away from minimum value. So that's why I use xij minus xj mean. And in this case, in case of non-beneficial criteria, I should be having the direction of the criteria should towards minimum. That means it should be away from max side. So that's why it is used as xj plus minus xij. Or in other sense, it is xij. This is called over the whole range, that is xj plus minus xj minus, and in that case it is also whole range, that is xj plus minus xj minus, or you can say xij minus xj plus divided by xij minus xj plus. So you can say, so this is the normalization. So this normalization is used. Then we used weighted theoretical rating into these normalization factors. Then we find out the difference between theoretical and actual. Then we get total gap. If theoretical and actual doesn't have, ideally the gap should be zero. If that gap is not zero, in real case it should be as minimum as possible. So this is the way we define this particular the values of final score values of alternatives, and accordingly the alternatives are ranked. The alternative which has rank 1 is the best possible alternative. Now, this case study is presented, description of the problem is given, how who the experts took part in the study. So, who are the experts? How did we get those experts? How do we set the criteria? This is a description of the decision makers, that how many experience, what is the degree. Then round two is the expert team. Then we collect the expert opinion. But it's important to have what do I say, expert opinion combinations. Then we calculate the score values. They are the opinions that must be mentioned in the paper. So opinions are given. Then we have, for each opinion, there is a linguistic scale, and for each linguistic scale, there is a formatting fuzzy set. So we have this, and accordingly, we use this fuzzy. Now, first, we need to understand what would be the criteria set. This particular problem initially identified 28 such criteria, but it becomes not 28 criteria important or significant for comparison purpose. So we used a Delphi method, Fermatin Fuzzy Delphi method. So there we used a technique Fermatin Fuzzy Delphi, and then we calculated the values are there, and those who are critical values above critical level, very important, those criteria we consider, and accordingly we set the criteria set. Then we have a linguistic rating scale. These are choices, alternatives available. This is my linguistic rating scale. Rating is given. Then again the aggregation takes place. Then we rank, set the criteria. This is the formation of the mixed integer linear programming model to solve and get the criteria weight. So we define the criteria weight. Then we go for the score values of criteria weight, and then we use this criteria weight for aggregated matrix to get the final theoretical matrix. Then we get the real rating matrix, and finally we arrive at the kind of final score of the alternatives, that is here the final score of the alternatives, and we finally rank the alternative. Now, after MCDM problem we rank, it is important to have a validation and sensitivity analysis. For validation, we do for two tests. One is the rank reversal test. What is rank reversal? You know, in an MCDM problem, we have a finite number of alternatives and we have a finite number of criteria. Now, in some situations, it might happen that some alternative may be excluded or may be included. The same can happen with the criteria set. Some criteria may be added, some criteria may be removed. Now, rank reversal phenomena is one where if any disturbance happens with the criteria set and alternative set, the initial ranking order gets disturbed. That phenomena is called rank reversal phenomena. So in this case, we deliberately remove some alternative and criteria set and we rank this. So we got that there is no such rank reversal phenomena. Now we compared the same thing with other methods also, just to have the confirmation that they are in the same line. And this is the Spearman rank correlation test, which suggests that method is all right. And then sensitivity analysis. What is sensitivity analysis? Is that suppose I change the normalization method, suppose I change the criteria weight, suppose I change the way decision matrix formed, parameters values. So whether my result gets disturbed or not, that should be checked. And that is the purview of, under the purview of sensitivity analysis. So in this case, deliberately we change these beta values, that is the aggregation parameters, and we rank, in each case we perform the Kruskal-Wallis test. So we did not find any kind of significant change, and that is suggested through this diagram. No significant changes are there. So we can say that the method is quite stable method. So then we need to write that these are all things we need to write in the discussion section. That what you found, what you infer, what you could not found, what is the possible advantage of the method, what is the possible disadvantage, everything, and what is the relation of the findings with respect to the past studies and your research question. That is should be mentioned in the discussion section, and research implications are mentioned. Then finally, you go for conclusive remarks, where you conclude the paper and give you the remarks. Now I would go back to the last part of my presentation, that is writing research paper. A very brief, I would touch very brief on this part. For writing research paper with my limited experience and knowledge of publication over the last few years, and with my experience of working with some of the renowned scientists in this field, what I could understand, that topic is very, very important. If the topic has no novelty, that means it doesn't attract the reader as well as the editor. In fact, if we look at the topic and the title, that must be in sync. In fact, and given the abstract, next is the title. So, what is title? The title should pinpoint your problem area, but it should not be too clumsy, annoying, or too long. It should not be too short. And of course, exceptions are there. In fact, the famous article in management domain, that is the balance Kaplan not on balance scorecard. The title is the balance scorecard. The only thing is this, the balance scorecard. Nowadays, an interesting trends are there to give a philosophical kind of interesting, catchy title. For example, the other day, I was reading some other paper, searching for a paper in Google Scholar. Then I came across one article. The title is, "If you are in San Diego, let's get into a dinner. Let's have a dinner or lunch." I repeat the title. The title was that like that. "If you are in San Diego, let's have a dinner or something like dinner or lunch." So initially, when I came across this title, I was very much astonished. I mean, what the man wants to say? What is the message that the researcher wants to populate? And that immediately catches my mind, and I just started reading the abstract. To my utter surprise, I found that it is about behavioral finance article, and written by some of the famous researcher in the domain of behavioral scientists, that is Zidonas, behavioral finance domain. And the article is very crispy, yet so powerful article. So that type of, sometimes people are doing that type of catchy title, but that is very much prescribed for the experts. But at the beginner, at a novice or beginner like us, we prefer to use a title which is pinpointing our objective. Abstract, I already said, is a matter of great precision, because it is the first paragraph that actually makes or breaks your paper. In the introduction section, you must first start with the background of the paper, the topic, why have you taken this topic, why one should read this, then what one is expecting to know from this, How did you approach? What is the uniqueness of your approach? What is the objective of your research? And then what is the uniqueness of your problem? That is very important to write, which is known as novelty of your study and contributions of the study. So, introduction sector most time fails to motivate, lack of focus. Theory is very important. How did you select the criteria? How did you select the variables? How did you select the methodology? Why this problem is important? So that is must be backed by some theoretical foundation. So that theory building is important. Literature review, it must be crisp, it must be to the point, yet not so long. It must highlight, you can say it's a critic's view of the past studies. Whatever past studies have been made, it's a critic's view that what has been made and what has not been searched out. Then methodology should have a completeness, clarity, credibility, and we come to the discussions. The first two, three paragraphs summarizing your paragraphs, theoretical implications, practical limitations, and conclusion. You very brief restating your research topic, summarize the main point, and very important. This part is very very important. Conclude your thoughts because you need to first finally conclude what you are thinking. It's a kind of directions, and and that's the way people write a paper. Very short idea about that. So thank you very much. You can contact me if you require. I would be happy to answer your queries now or later on. You have my email ID sanjeevb@acm.org, and you can search my Google Scholar. You can. I would love to clarify some of my papers if you really are interested. So with this, I rest my case here. I would like to answer the questions or queries which you can have.
Thank you, sir. Myself, Shiv Prasad, Assistant Professor in IT Department. And sir, I got some questions from the audience. So first question from Arun Kumar Mandal, sir. He
Mhm.
asks, what are the basic components of soft computing and how it can be distinguished from hard softing?
Now, hard computing, soft computing is we can say it's a field of approximation. As I said, for example, you take the logic of fuzzy sets. I explained very categorically. If you go for preset based analysis, that means you have a deterministic model. You know the model, you know the formation, you know the assumptions, you know these things. But when it comes to impreciseness, approximation, then you go for fudge. You define variable degree of membership. And at the same time, you know the beauty of approximation is it works in two ways. One is the towards the membership, towards the non-membership aspect. And in between, there's a degree of hesitance. That means it is not a hard way to determine which one is the best solution. It is a soft or approximate way of finding out what is the best solution. This is regarding the fuzzy. You talk about genetic algorithm. You talk about, evolutionary algorithm. It works with a very basic concepts or very natural phenomena or crossover mechanism. It generates solutions after solutions, and then it compares each such solution to arrive at the final thing. So that means it works on heuristics kind of thing. That is the soft computing elements.
Yes, sir. And next question, sir. What are the best practice for implementing multi-criteria based soft computing models with limited data and high uncertainty?
You see, it depends on, as I said, it depends on several aspects. For example, one situation may be there where you have only three response. Suppose you ask, do you like this AR augmented reality? Now, the same question, I take this example because it's a very implications. Listen carefully. If the same question, if I ask to a IT professional, then I said, do you like AR-based product? Strongly disagree, like at 5 scale, 7 scale, I can say. But there, that means there, I can have for each scale membership and non-membership functions. But if I ask the same question to a low literate person, then I form the questions like this: Do you like? The answer would be yes, the answer would be no, the answer would be can't say, and the answer may be I don't take into participate this. So if I get the answers in yes, no, can't say, refusal, we go for picture sets, picture fuzzy sets. If I know this question is known to the respondent, then I may go for like a 5 point scale. There I can use fuzzy, there I can use intuitionistic fuzzy, there I can use this spherical fuzzy. Now it depends on to what extent impreciseness is there. If the impreciseness degree is less, I may go for IFS. If the degree is high, I gradually increase the upper versions.
Yes, sir. And next, this is the last question, sir. What are the potential area of integrating multi-criteria based soft computing with other advanced analytics or AI models?
Of course, this is a very fantastic question, I must say. And then I just give one particular example. You know that there is an interesting study that that works with British Soccer League, and it says that who is the best player. Now, this best player, it depends on it depends on experts' opinion. It depends on the actual performance. The values are there, and also it depends on lot of perceptions about the player created on social media. Now, the author did what the author did. The author did one analysis based on the performance record, one analysis based on the soft computing model based taking on the football experts' views. And the second last one, he has drawn the public sentiment from Twitter, from the social media, and he tries to find out what is the sentiment of the people about this particular player. Is it in a positive sentiments? Is it in a neutral? Is it in a so that means he integrates natural language processing, back-end natural language processing with front-end MCDM technique. That is one area. Second area is, I mean, the area has started that people are working with future state MCDM. So people use something called neural networks, support vector machines, classifiers, algorithm, or predictive model to predict the future decision matrix. That means I have historical data, I predict the future state of matrix, then I apply MCDM. So these are the areas, some of the areas where you can integrate ANN with this.
Okay, sir. Thank you. Thanks for giving your valuable time to
Thank you
enlighten
so
us.
much. Okay, but my email ID is with Professor Modo. So if any further queries come, I would love to answer those queries.
Yes, sir.
So I may be excused.
Yes.
I can. So once again, thank you to the organizers and have a great workshop ahead. Thank you.
Thank you, sir.
Thank you, sir. Okay, thank you all for
Yes.
joining the session and all the best for the next session. And I hope all of you will join join that particular session. We have remaining two sessions tomorrow,
Yes. Yes, sir.
and tomorrow we will also have uh, questions for the certification. There are, I think, there will be some questions. Some one thing is that was quiz. So quiz will be happen on tomorrow session, second session.
Okay. The last session. Okay, sir. I'll
Yes.
inform that. Okay. Thank you, sir.